right, welcome back. Continuing our unit on the solar system, but what we're going to focus on today is Earth's moon, the different phases that the moon goes through, eclipses, and of course tides, which really affect us, of course, here down in Florida. Now, what's the moon like? All right, so only a few people have been there. And we haven't always known a whole lot about the moon. But in 1609, when Galileo invented his telescope, he was able to look at the moon and he was able to see that there were these different features on it that you couldn't just see with the naked eye. The moon is dry and airless. It has a bumpy, irregular surface. It's small. The temperature varies depending on its location with the Earth and the Sun system. But some of the things that we can find on the moon. We can find these dark flat areas that are called maria. And of course, since we believe that the moon was originally part of Earth, we know that it is a lot of hardened rock and that it was probably lava flows that created those dark flat areas. Now, during the formation of our solar system and when the moon got knocked off from Earth, of course it continued to have impacts from meteoroids. And so there are a lot of craters across the surface of the moon because of that. There are also some lighter colored areas on the moon, and those are called the highlands, or almost like mountains. Those are, higher areas. They cover most of the moon's surface. Okay, the moon is small. We can see here this scale sort of diagram of the moon. It's 3,476 kilometers across. So that is smaller than the United States. And of course, gravity is less on the moon. And so you would weigh less on the moon. You could jump higher and farther on the moon. And the temperature. At the equator, where there is direct sunlight, the temperature of the moon can range from 130 degrees in that direct sunlight to negative 170 degrees when during its nighttime. Of course, the temperatures on the poles are more extreme. And because there is no atmosphere on the moon, the moon doesn't hold on to any of that heat that it might get during its day. And so it does get very cold. Again, we believe that something collided with Earth during the formation of Earth and the rest of the solar system. And so part of Earth's mantle was sort of pushed off into orbit around Earth, and that is how our moon formed. Now, we know that when we look at the night sky, we can see these different shapes. So why is it that we have these different shapes or phases? It is just because of the Earth, moon, and sun system. So how those three major objects line up. Now, sorry about that, Mr. Stockman. We always see the same side of the moon, or the near side of the moon. And the reason for that is because the moon, not only is it orbiting around Earth, but it is also rotating on its own axis. And so we do always see the same side of the moon. Now, if we're looking at this, okay, look at that, how the moon orbits around Earth, we can see that there are times when we have a new moon. We don't see any of the moon. There are times when, as the moon moves around, that more of that sunlight begins to be seen, the reflection of the sunlight begins to be seen by Earth. As notice, it is happening from the right to the left, always from the right to the left. And we can see that initially it looks like a crescent shape. That is called a waxing crescent. Then we move into our first quarter. Waxing gibbous is when we can see 3/4 of the moon. And then finally a full moon, where we see that full moon in the night sky. Then, as the moon continues in its orbit around Earth, the shadow starts to move back over. And we can see again, this is happening from the right to the left. Waning gibbous, because again, we see 3/4 of the moon. Last quarter, and then a waning crescent, where we can see that last little sliver of the moon. So, if again, we look at the position of the sun, the moon, and the earth, you can see that half of the moon is constantly lit by the sun, but it's all with relation to its alignment with the earth that changes what we see. Now, because because the orbit is slightly tilted, the moon typically travels just above or below Earth's orbit. But there are rare occasions when the sun, the earth, and the moon do line up. And for that reason, shadows are cast, and those are called eclipses. Oops. Now, during a new moon, where the moon lies between the earth and the sun, and so we don't see any of the moon, that is when a solar eclipse could occur, because that is when the moon is passing directly between the earth and the sun. Okay, sorry for that interruption. Getting back to solar eclipses, they can only occur when the moon passes directly between the earth and the sun, and so it's blocking sunlight from earth, and that way, or what happens then is that there is a shadow on Earth up from the moon. And of course, that can only happen during the new moon phase. Now, there are a couple different parts of an eclipse. The darkest part of the shadow is called the umbra, and you can see a great picture of the umbra here. So we have the sun illuminating, or excuse me, shining onto, in this case, the Earth, and we can see the shadow behind the earth that would be projected onto the moon. And so we can see here the umbra and the penumbra is that less dark area. The moon will cast a shadow that is less dark, and again, that's the penumbra. Now, during a lunar eclipse, that's something that's going to happen during a full moon, when the earth is then directly between the moon and the sun. And so Earth is blocking sunlight from reaching the moon in that case. And then when the moon, so we can see here again, the Earth is blocking the sunlight from reaching the moon. And again, that would happen, like I said earlier, during a full moon typically. And you can see that the Earth blocking the sunlight is creating an umbra on the moon. And again, those less dark areas would be the penumbra. Now, this is what I really want to focus on for today, the tide cycle. We know that tides are, the water levels on Earth are affected by the pull of the moon and Earth and somewhat the sun as well. So at any time on Earth, we can see that there are going to be areas where there are high tides and there are going to be areas where there are low tides. Now, again, the sun does also play a role in our tides, and so it is this whole sun, earth, and moon relationship that creates and affects the height of the tides. Now, when the sun, the moon, and the earth are nearly in line, the gravity of the sun and the moon will pull in the same direction, and that forces the high tides to be higher, the low tides to be lower, and that situation is called a spring tide. Now, when the sun, the earth, and the moon almost make up a right angle, the sun and the moon are pulling against each other, and so the high tides are not quite as high, the low tides are not quite as low. Excuse me. And that would be a neap tide. Okay, we are going to work on plotting the tidal charts to help us get a better understanding of that, and we are also going to work a bit more on eclipses in class, so hopefully that gives you a great introduction into all of that. All right, guys, talk to you later.